So I'm going to try doing some more advanced examples of derivatives with natural log. You can see I already started this one because my value version of webcasting equipment appeared to not be working at school, so I'm making this at home. Just like any other derivative of natural logs, you want to just kind of, if you think about ignoring what's on the inside and just say, I know I'm going to take the derivative of whatever is under there over itself. So I wrote the inside over here as u and u prime, but the derivative of whatever's under there, well, what's under there is natural log, so the derivative of that's 1 over x. And all of that over ln x. And then put over 1 so you can simplify. 1 over x times 1 over ln it. The second one, I'm going in order here. The second one looks a little more complex, and you say, well, if I had to take the derivative of x minus 1 over x plus 1, the third root, all over itself, that's a big mess. But in reality, you make this easier by just doing some properties of logs that we talked about earlier. So you can split apart this log. Because this is the 1/3 power, you can put the 1/3 out front, and then we have natural log of x minus 1 minus natural log of x plus 1. Those derivatives are much easier than doing a big old chain rule problem. And so then you can just take the derivative of each individual part. Natural log derivative be u prime over u prime is 1. So 1 over x minus 1, and then 1 over x plus 1. Find a common denominator, which would be x minus 1, x plus 1. And so x plus 1 for the first fraction, because it's missing the x plus 1, minus x minus 1 for the second fraction, which just gives you x minus x, which is 0, and 1 plus 1, which is 2. So your final answer would be 2 over 3 x minus 1, x plus 1. And that would be the derivative. Things to pay attention to when you have natural log, you often have undefined values because of the denominator. With the trig functions, again following your same rules, they often simplify down to something much easier. The derivative of the numerator would be secant x tangent x plus secant squared x. So all over secant x plus tangent x. And then something will usually factor out. If you factor out a secant x from the numerator, you're left with tangent x plus secant x all over secant x plus tangent x, which is awesome and super cool, exciting stuff, because that cancels out. So the derivative of the natural log of secant plus tangent is secant. And that is going to show up later. This is exciting math foreshadowing. When we learn to do integrals of trig functions, we will find out that natural log is involved in the ones that you didn't already know. So like you knew the integral of cosine, you're going to know the integral of secant as a natural log, but I don't want to ruin all the fun by telling you about it right now. Second one, take the derivative. Derivative of cosecant is negative cosecant cotangent all over cosecant. Again, plenty of nice reducing that happens. Cosecants cancel out. You get negative cotangent of x. So those are some more of the complex versions of derivatives of natural logs that go along with the notes. So you're able to do the assignment.